Welcome to the debate. So for the last 10 years or so, quantum computing has basically been a miracle locked in a vault.
Oh, absolutely. It's been entirely walled off.
Right. I mean, you could look at it through the cloud, maybe run a few narrow experiments, but you absolutely could not bring it home. And that walled garden approach, which has really been dominated by Western players like IBM and Google, has just been shattered.
It really has. I mean, China's Origin quantum computing technology, releasing Origin Pilot V4.0, it's a massive shift. We are looking at the world's first full-scale quantum operating system that's actually built specifically for local, production-grade deployment.
Exactly. The proprietary cloud-only access model is officially disrupted. But that brings us to the core disagreement we are diving into today, the crucial question of how we build enterprise data infrastructure right now. Does Origin Pilot V4.0 mean quantum computing is an immediate, active architectural requirement for enterprise data teams today? Or, and this is the flip side, does its 3 to 5 year integration runway indicate that it remains primarily just a preparatory framework for future infrastructure?
Right, and that timeline is exactly where we diverge. I will argue that the system is ultimately an orchestration layer abstracting some genuinely unresolved physics problems, making it a critical preparatory tool for a 3 to 5 year horizon, rather than, an immediate enterprise deployment.
And I will argue that the local deployment model, and specifically its solution to data sovereignty, make quantum readiness an immediate active architectural concern that fundamentally changes pipeline design today.
Well, I'm certainly ready to get into it.
Let's do it. To understand why this requires immediate action, we have to look at the mechanics of what has actually been holding enterprise quantum back. For a decade, the access model for quantum computing has been fundamentally broken for the entities that actually need it the most.
You mean in terms of cloud access?
Yes, exactly. We have had brilliant science, sure. But if a data engineer wanted to run a quantum workload, they were entirely bound by the latency, the opaque pricing models, and, most importantly, the data sovereignty constraints of Western cloud providers. Origin Pilot V4.0 changes that math entirely. By running on premises, this operating system opens the door for highly regulated industries.
Right, the sectors that are effectively locked out today.
Precisely, think defense, global finance, pharmaceuticals. These are sectors that legally cannot send their most sensitive, proprietary datasets over a public wire to some third-party quantum cloud. Now that they have a local deployment option, data engineers in these industries must treat hybrid quantum classical pipeline design as a real, active conversation right now, not some theoretical exercise slated for the 2030s.
Look, I don't disagree that the software architecture we are seeing in Origin Pilot V4.0 is a genuine breakthrough. It is, frankly, a remarkable piece of engineering.
It really is.
But we have to separate the software achievement from the physical realities of enterprise integration. The timeline for active integration remains 3 to 5 years away at an absolute minimum. And here's why. An operating system in the quantum realm serves as a sort of soft heart. It acts as an abstraction layer for genuinely difficult, unresolved physics problems.
Unresolved physics problems? Like what specifically? Because they are running workloads on it now.
I am talking about the core mechanics of quantum states. You have cubic superposition, right? Where a particle exists in multiple probability states simultaneously. You have entanglement, where qubits are perfectly correlated so an action on one instantly affects the other.
Right, the fundamental building blocks.
Exactly. And because of those incredibly delicate states, you have an extreme sensitivity to environmental noise, which leads to decoherence. That's when the quantum state just collapses and you get random, useless classical noise. Because this operating system sits as a layer between incredibly volatile quantum hardware and stable classical high-performance computing, its immediate value isn't in pure quantum computation.
So you're saying it's more of a bridge?
Yes, its value today is in quantum-assisted optimization running alongside classical AI. That makes this a space to rigorously monitor and prepare for, rather than a system you can reliably deploy in production today.
I see why you think that, but let me give you a different perspective on how data actually behaves in an enterprise environment. Have you ever dealt with the concept of data gravity?
Of course.
The idea that massive data sets attract applications and processing power to them rather than the other way around.
Exactly. Back in 2015, during the first major wave of enterprise cloud adoption, we saw that massive, sensitive data sets possess this sort of gravitational pull. It is incredibly difficult, financially prohibitive, and legally risky to move 50 petabytes of highly regulated financial trading models or genomic sequences into the cloud.
Sure, you're dealing with bandwidth costs, latency.
And compliance audits, exactly. The Western cloud-centric quantum model creates that exact same data gravity problem today. It fundamentally prevents organizations with the most complex data sets, the ones with the most to gain from quantum computing, from even participating.
Right, because the data is too heavy and too sensitive to move to IBM's or Google servers.
When the cloud-first mandate collides with strict data sovereignty requirements, sovereignty always wins. A bank is not going to hand over its core algorithmic trading logic to a public quantum cloud. Origin Pilot V4.0 gives those organizations the bridge they need today. They can bring the compute to the data, rather than trying to drag the data to the compute.
I come at it from a different way. You are absolutely right about the data sovereignty unlock. I mean, cloud repatriation is a very real trend right now, and organizations clearly want control over their infrastructure. But downloading an on-premises operating system doesn't magically stabilize the volatile hardware required to actually run it. You are talking about deploying this in enterprise data centers.
Right. Bringing the quantum processor right into the local server room.
But let's look at the physical reality of that server room. We are dealing with quantum hardware that is so fragile it borders on the absurd.
Wait, give us a sense of scale here. How fragile are we really talking about when it comes to enterprise deployment?
We are talking about hardware that can be completely destabilized by ambient vibration from a server cooling fan.
A fan?
Yes, a slight fluctuation in the electromagnetic field from a neighboring classical server rack or even stray cosmic rays can cause a qubit to undergo decoherence. Remember, for a quantum computer to work, it basically has to isolate the qubits from the rest of the universe. In the case of superconducting qubits, they have to be cooled down to millikelvin temperatures. That is literally colder than deep space.
Right.
So yes, you have solved the software and sovereignty side of the equation. You have an OS that can live locally, but you are bringing a highly theoretical, physically fragile piece of hardware into a rugged, noisy, vibrating classical computing environment. The physical realities of quantum hardware simply don't match the readiness of this software yet. You can't just rack mount a dilution refrigerator next to your standard database servers and expect it to work flawlessly.
But that is exactly where Origin Pilot V4.0's architecture is so brilliant. And it directly addresses your hardware skepticism. The system employs a dual-service framework. It separates the quantum and classical concerns while maintaining incredibly tight integration. And more importantly, it features what I would call a sleeper feature, which is its hardware agnosticism.
Hardware agnosticism, meaning it doesn't care what physical machine is sitting underneath it.
Exactly. It currently supports 4 distinct hardware backends. You've got superconducting, ion trap, neutral atom, and photonic. By abstracting the physics problems away from the user, it acts as a true production-grade orchestration layer. It manages multi-user resource contention. It reduces latency bottlenecks between the classical processor and the quantum unit right now.
But the hardware underneath is still...
The point is, you don't need perfect, fault-tolerant hardware if you have software that can efficiently orchestrate a hybrid workload. The OS passes the heavy mathematical lifting back and forth between classical AI and the quantum processor. This widens the competitive gap immensely between Chinese infrastructure software and the Western narratives that are still obsessing over hardware error correction benchmarks. The software is ready to orchestrate whatever hardware you plug into it.
That's a compelling argument, but have you considered what that hardware agnosticism actually proves about the state of the industry?
I think it proves maturity. It proves flexibility.
I think it proves profound uncertainty. The fact that Origin Pilot V4.0 is forced to support 4 vastly different physics backends proves that the underlying hardware standard is completely unsettled. Let's break down what those 4 backends actually are, because they aren't just different brands of the same technology.
Sure.
Superconducting circuits require those massive cryogenic refrigerators cooled to near absolute zero, like we talked about. Ion traps use lasers to suspend charged atoms in electromagnetic fields in a vacuum. Neutral atoms use optical tweezers, and photonics use particles of light traveling through waveguides at room temperature.
Right. They represent entirely different branches of applied physics.
Exactly. They are entirely different domains of physics. The necessity of supporting all of them means that nobody on Earth knows which physical approach will actually scale to 1,000,000 qubits. The fact that an enterprise doesn't have to make a single hardware bet today is just a polite way of saying that no single hardware is truly ready for enterprise dominance.
If the foundation is still fractured across 4 entirely different domains of physics, how can you ask a data engineering team to restructure their entire pipeline architecture around it today? You are essentially asking them to build a house on tectonic plates that are still actively shifting. Because the architecture of the data pipeline is independent of the winning hardware. That is the entire point of an operating system. When you write a Python script today, you don't rewrite it depending on whether it's running on an Intel chip or an AMD chip. The operating system is doing the translation.
But quantum is completely different from classical chips.
Origin Pilot V4.0 is doing that exact translation for quantum. If you wait for the hardware wars to settle, if you wait to see whether photonics beats superconducting, you will be years behind on the orchestration logic.
I'm sorry, but I just don't buy that. Let me tell you why. If we look at the reality of data engineering teams today, most are roughly 3 to 5 years away from needing to make active integration decisions. The practical engineering steps for today are not ripping up your pipeline architecture to accommodate a photonics or ion trap backend. The practical steps are auditing your data sovereignty posture and monitoring early use cases.
Monitoring is entirely passive, though.
It's strategic. We are talking about highly specific applications right now. Drug discovery, where you are simulating molecular interactions, logistics optimization for global shipping routes, financial risk modeling, and large-scale combinatorial problems. You monitor those spaces, you understand where quantum-assisted optimization might eventually fit alongside your classical AI pipelines, and you prepare. You do not deploy a fragile infrastructure into a production environment when the underlying physical standards haven't even been agreed upon by the global scientific community. You ensure your classical data is clean, and you wait for the hardware to stabilize.
I'm not convinced by that line of reasoning because it drastically underestimates the sheer amount of time it takes to build organizational capability, particularly around data structures. The engineers who will successfully lead these projects in 3 to 5 years are the ones building foundational literacy today. If you only ask, when will the quantum hardware be fully error-corrected and ready, you are asking the wrong question.
Then what's the right question?
The question data leaders must ask right now is, how would our data pipelines need to change if quantum processing became available on premises tomorrow?
But that's a thought experiment. It's a valuable one, sure, but it's not a deployment strategy. You don't overhaul your active production pipelines based on a what-if.
It is a thought experiment that surfaces very real dependencies in data format assumptions that are actively harming organizations today. Let's talk about the mechanism of data translation, because this is really the crux of the issue. Quantum computers do not just consume standard relational database tables. You cannot just point a quantum processor at a SQL database and hit run.
Correct. The data has to be mapped into a quantum state.
Exactly. Classical databases store binary data, ones and zeros. Initializing qubits requires entirely different data structures. You have to encode that classical data into quantum probability amplitudes. That process is known as state preparation, and mathematically, it is incredibly expensive.
Right.
If you have a massive data set, the time it takes just to load the classical data into the quantum computer can completely erase any speed advantage the quantum algorithm gives you in the first place.
Orchestrating a hybrid workflow where classical AI narrows down a massive data set, isolates the complex combinatorial problem, and passes only that optimized subset to a quantum processor requires you to completely rethink latency, state management, and data flow.
Which is incredibly complex. I completely agree. It is. And if you wait until the hardware is perfectly stable in 3 to 5 years, you will spend the following 5 years just trying to clean, format, and structure your data to be quantum ready. The lab doors are open now. The software to orchestrate this translation, Origin Pilot V4.0, is available now. The organizations that treat this as an immediate architectural concern, the ones figuring out how to structure hybrid AI quantum pipelines today, are the ones who will survive the transition. Everyone else will be left holding beautifully stable hardware with 5 years of data architecture debt preventing them from using it.
Look, I think we can certainly agree on one fundamental truth emerging from this development. Origin Pilot V4.0 is a genuine architectural contribution. It proves that infrastructure software matters just as much as qubit counts and error correction benchmarks. For a decade, all anyone talked about was physical qubits.
Right, the hardware obsession.
Exactly. And this operating system solves real orchestration problems at the abstraction layer. It provides a credible model for how quantum computing can eventually be governed and integrated into existing enterprise environments rather than just isolated in academic labs.
Absolutely. The days of treating quantum computing purely as a hardware race are over. Software infrastructure is the bridge that makes the hardware usable. It abstracts the physics so the engineers can focus on the logic. Where we clearly remain at odds, though, is the urgency of action. I look at the local deployment capability and the resolution of the data sovereignty problem, and I see a mandate for immediate pipeline restructuring. Regulated industries finally have a way to break free of those Western cloud-locked models, and they need to start building the hybrid data pathways today.
And I look at the physical realities of the hardware, the necessity of an abstraction layer to manage unresolved physics like decoherence, and the entirely unsettled nature of the backends from lasers to dilution refrigerators. Well, it tells a different story. To me, it signals the initiation of a critical 3 to 5 year preparation phase for hybrid AI quantum workflows. The software has indeed arrived, and it is brilliant, but the physical reality still requires a tremendous amount of patience before we start ripping up enterprise data centers.
Well, complexity always requires multiple perspectives to fully appreciate. Origin Pilot V4.0 has undeniably changed the rules of the game. We suggest that you dive deeper into the implications of on-premises quantum infrastructure for your own specific industries, whether you are dealing with financial models or pharmaceutical simulations.
Indeed, because while you may finally have the software blueprints to build your own high-speed tracks, you still have to figure out how to lay them down without the whole physical system vibrating apart.
The lab doors are officially open. The only question is whether you are paying attention.